says that one needs pure uranium-235 for a bomb, right?
He says what?
That one needs pure uranium-235 for a bomb.
Yeah.
And not because of a different cross-section, that he didn't know, as you said, but he says because he wants to avoid resonance absorption in uranium-238. But resonance absorption is not a matter of fast neutrons.
The mathematics that he worked out
is not. This is
is
not
correct.
a
Yeah.
fast-
Okay. So he did not. He didn't understand He didn't understand that. That's
it
true.
was not a
Yeah.
fast neutron bomb what he
Yeah.
described, because otherwise you also find in the Heereswaffenamt report, you find that the fast Newton fission of U-35 was not under consideration. It's not mentioned.
Sorry.
So
It's,
the part that the Heereswaffenamt report says there are two ways of producing energy from uranium. One is fission with thermal neutrons from 235 and fission with fast neutrons from 238. The fission with fast neutron from 235 is missing, it's not mentioned. And there has never been an attempt to measure the cross-section of fast fission to 235. He didn't know it up to 45, they had agreed.
Right.
So whatever you have found as similarities, it is the conception, Heisenberg's conception is a bomb with thermal neutrons. There's no doubt, otherwise he would not have talked about...
No, not in 1945. He says the speed of the bombs...
45,
Yeah.
yes, he had
Right.
learned it by the time.
Yeah.
But in 39, he had a different... It may be that the calculations coincidentally are similar, but this is then still a totally unrealistic bomb concept.
No, the whole theory is the same. It's not
The
similar.
theory is the same,
It's
but
identical.
the practice is- He has a...
He never...
Still, he is not talking about a fast fission bomb.
That's right. In 1939, he is
agree
not
on
talking,
that.
I never said that. He's
Yeah.
not talking about fast fission. But the equation, the theory is identical for reactor
Yes,
and bomb.
but if he would have started to build a bomb on this basis, it would be a disaster.
Well, he could have started, could have started in 40 or 41, and they might have had more
Go on.
information.
Okay. I hope you agree with me to disagree with you. It's
Go ahead.
put it in this way.
I'm used to it.
Okay, the equations that you have presented are, or what Heisenberg did it, is the wrong way to do it from the modern point of physics, if I call it from this way. They're simply wrong.
But it's not,
So-
it's
so
not
the
reactor
point-
construction, but it's...
No, it's exactly, it's a mix of not understanding the diffusion equation. First of all, you don't build a reactor with a diffusion equation. You need, this works only with very big dimensions.
Well, then you can say he tried to build a reactor with a diffusion equation and he had bomb theory.
I don't talk about bombs. I
Okay,
just said
but
the reason,
it's all
the
the
way
same.
to do it, and here is his mistake. You have, the way, okay, I will present it in another way. I don't want to go into it. This is what you call buckling. So you have you cannot put critical values together with material, because the way you do it, you have the dimension on one side, and then you have the material on the other side.
Yeah, but you're an
And
expert.
then you have to differ also between critical material and fissionable material and non-fissionable material, because the equation, the diffusion equation, are not the same. It's not the same equation. So what you showed here is
You
indeed a mix that
For a mix.
this is a mix. What Heisenberg did was a mix of putting non-fissionable material together with fissionable material, because the diffusion coefficient is not that way. And what you showed here on the geometry is indeed what today you calculated, and which is the comparing the buckling geometry, meaning you have to have a big size together with enough materials. So this is the way you would do it today, or you would understand it. And
Not the way you would build a reactor today, but at that time, that's what they were thinking.
And that was wrong.
But that was correct for a bomb.
I don't know. Okay, I don't think, maybe the point is that, first of all, I wouldn't build a bomb with a diffusion equation.
Yeah,
But
but
they did. Okay, maybe I don't.
It worked
okay.
pretty well.
Okay, definitely there are two things where this cannot be connected, and this is a bomb and a reactor. First of all, what you have mentioned, okay, with all due respect, working 20 years on cross sections, you don't give a cross section without energy. So the cross section, and this was Heisenberg, the resonances and so on. So you can take an average cross section, but and not.
No, he's not averaging over thermal and fast. He uses thermal in one case and then fast in the other case. He's not taking an average.
Okay, that's I will show in my presentation a little bit what is a cross section. So you see, it's very energy dependent.
We can yeah, but you have the case of cross sections for near the speed of light, cross sections for thermal. Two separate cases.
Yeah, you can do the average.
Yeah.
So therefore,
no, you don't take an average. You just take one or the other.
Yeah, you can take numbers, but the issue that was mentioned just now also by Manfred, that it's completely different. The idea, if you have thermal neutrons, then you have the issues of resonances, and you have the issues of moderation, then you have the issues of diffusion lengths in the moderator.
Yeah, I'm sure you know much more about reactors now than you did then.
Yeah, but sorry.
Therefore, I'm just saying that I just finished, and then your turn. It's no okay. That will be my presentation, so I'm preparing so I can finish earlier. It's this diffusion equation, yeah, which is, as it's been written here, wrong. There is other issues of temperature and so on, and the cross section itself, it didn't work. So it is the right direction. I would never. I mean, it's amazing that what he came up with 1939. But for me, it's no wonder then if he started with this equation, then he didn't come to the right assumption.
Well, even for the bomb, the mean free path was too big. But the point is, you have a reflector, so the neutrons get shot back in, and so the diffusion equation worked pretty well because of the tamper, I would say.
Okay, a reflector is a reflector. Today we calculate it, and we calculate the reflective saving. So, but on the whole, this equation is a little bit problematic.
Yeah, but this is 2024.
Alexander Bloom.
Thank you. Just so for me to thank you for the talk, it was very interesting. Just for me to understand the whole controversy also better. What you're saying is that in the two calculations, the 39 to 45, the only difference between slow neutrons and thermal neutrons and fast neutrons is changes in the values of the parameters.
Yeah.
So there's no qualitative difference that gets introduced into the equations by, say, the presence of a moderator.
That's right.
That's the central thing.
That's right, because that comes into the cross sections, because the neutron source goes away at criticality.
Okay, good. Then I just want to make sure that I understood that is.
Yeah.
Thank you.
Well, about your discussion, your differences, is not the more core question, what did the Americans do in that time? What were their basis of data and what equations did they use? I mean, as you say, today, maybe one has to start from a different point, right? With not the, what did you say, with the material or whatever. But I mean, what did the Oppenheimer team use?
I think he overcame this. If you ask me, I will show some of it in my presentation to understand, because there are more parameters, so there are several parameters. And if you overcome one parameter by changing it drastically, then you can come. So I think, as Joe said, they were really, did not take change to be critical. This is a bomb, so you get very strongly overcritical. And the point is, the way you do it, for example, is you increase the density of the material, and with that you increase what we call the macroscopic cross-section. So what was said here is correct in a sense that for the beginning, but, and that therefore I think, okay, we saw Heigerloch and so on, it wouldn't have worked. You need to compensate it somehow, and probably that's what they did.
What they probably did, but you don't know.
About the bomb, I don't know. About reactors.
Okay, I think you, as you said, this is still a case that is very similar what comes out, but in a theory, but in practice it would have been not a bomb what he designed, but an exploding reactor.
No,
he was just running with thermal neutrons, and if he would build a bomb
But
it would have been a disaster.
did he suddenly, out of the blue, know that the speed of the neutrons is close to the speed of light in 1945? He knew that.
It is no coincidence.
You know that when you calculate the energy release from fission, that the 2 MeV neutrons are moving at close to the speed of
And,
light. He knew that.
your solution doesn't make things better in a way, because if you really accept this, then you have a lot of new questions. Why did Heisenberg not tell what he knew
I think he
clearly?
didn't
Why
want to.
did
He
he
didn't
not?
want
Very
to.
simple. He didn't
Why
want
did
to.
he not start a bomb program? Why did he not ask to have the fast fission cross-section of 235 measured? Because that would be the next step to have a better calculation. If he would have had to look for the exact value.
I think he didn't
All
want to.
this did not happen, and you have to explain all this.
I think it's
And
simply.
I've made one more comment, and also in your own interest, please. I have not the impression that you disqualify people just because of their age.
Sorry?
But you disqualify
I would
people
have to
because of
I would have to
their age.
disqualify myself.
Because
I'm making it.
this is a dangerous path in here with my
Because
data.
Hans Bethe and Robert Serber were a lot better than that.
Okay, this is the
That's
right
why.
moment
They were a
for
lot
coffee
better
break.
than that.
Anyway, thank you, Joe, for your presentation. And a number of remarks at this point is in order. Okay, we have a coffee break. We are about 2 hours.